Hi, today I'm going to do a couple examples of uniform random variables. That's section 7.1. I believe that was on Monday, and so I think you're probably through the discrete problems now since with the quiz and everything like that. So, and then chapter 6 was just showing you in general properties of continuous random variables. And chapter 7 is just looking at some special ones. One of the special ones is a uniform. Another special one is a normal. And then we'll also look at an exponential. So let's just build this guy's probability density function. So it takes a professor a random time between 20 and 27 minutes to walk to school. That's probably true. If you live in Heritage Trail, that's probably about right. The professor has class at 9 a.m. Okay, and he leaves at 8:37. What's the probability he reaches his class on time? So let's see. The time it takes him in general to walk to class. Let's let x equal time to walk to class, and f of x equals wow, okay, so there's a 1/7 probability, so 27 minus 20, that x is between 20 and 27. So this is a valid density function. It integrates to 1 over the interval 20 to 27. And now we're trying to find what's the probability that the time to walk to school, if he makes it to class on time, that means it's less than, what is that, 60 minus 37. Oh, I shouldn't have to do this. That he makes it to school in 23 minutes. So what's the probability he makes it to school in less than 23 minutes and he'll be on time? Let me erase that so there's no evidence that I ever had to do that with Maple. Okay, so f of x is 1/7. And we can integrate f of x on the interval x equal 20 to 27 to see that it's valid, but we know that. So what's the probability that x is less than 23? So I'm going to integrate that line between 20 and 23. Should be right 3/7, because it's really just the line. I'm finding the area under the line from 20 to 23, right? I mean, let's just plot, right? So you know what I'm 20 to 27. So that's what this guy looks like. He should be up there at 1/7, and I'm just finding the area under the curve between 20 and 23. If I could just put a line right there, that little area there, 20 to 23, which is 3/7. How long do you expect the time to be on average for him to walk to school? So that's just the mean, and that should be right in the middle, right? So let's put under here expected value. Expected value is integrate f of x times x from x equal 20 to 27. What does have that? 23.5? Okay. So there's a uniform. It's pretty nice. It's just equally likely. So it's 1 over the length of the interval on that interval, and then you can calculate probabilities. You could just actually, do it in your head or draw a picture. You don't need an integral to see the area under a line. Really, it's just the area of a box then. Okay, so here's another one. Suppose that 15 points are selected at random and independently from the interval 0 to 1. So they're equally likely in the interval 0 to 1. How many of them can be expected to be greater than 3/4? So f of x is just 1 on the interval 0 to 1. It's equally likely anywhere in there. So if I integrate 1 on 0 to 1, it's 1. and I want to find the probability, well, not the probability, but the expected number that are greater than 3/4. So what's the probability of grabbing an x and it's greater than 3/4? I should have said x equal randomly chosen point on interval 0, 1. What's the probability I choose a point that's bigger than 3/4? That's what I want to figure out first, which we know is 1/4. Well, I'm not even going to integrate that, right? That's 1/4. So how many of them can be expected to be greater than 3/4? There's 15 points, there's 1/4 of a probability, so whatever 15 divided by 4 is. But really, this is a binomial. Let y equal number of points out of 15 greater than 3/4, where probability of success is 1/4. Yeah, that's a nice way of saying it. So expected value of y, that's a binomial, is just n times p, which is 15/4. So I actually don't even need to do any calculations here. So that's the uniform. It's fairly nice, so that was a nice way to start off Monday. And then I'll do a few videos on the normal distribution, some sample problems.